This is my transformations video clip. I selected the base function of y equals the absolute value of x. The following equation is the one that has had transformations applied to it. Each table shown here shows how each transformation affects the coordinates. T-table 1 represents the parent function coordinates. As you can see, the t-table shows the coordinates corresponding to the graph 1 shown here. Now, moving to t-table number 2, I'm going to explain the first component of the transformation. As you can see, there are actually two transformations applied in this case. The first is the fact that the added value is a negative number. This indicates that there is a reflection of the x-axis. Secondly, the value of 4 indicates a vertical stretch by a factor of 4, referring back to t-table 1, when x is negative 2, y was 2, and now with a negative 4 reflection and stretch, the y value is now negative 8. The trend is noted in all of the y values. Moving on to t-table 3, this shows a horizontal compression by a factor of 2. In this transformation, we note a change in the x values instead of the y values. This is interesting because we are affecting the independent variable instead of the dependent variable. As you can see, the parent function remains the same in red, while the blue now has 3 transformations applied to it. Moving on to t-table number 4, it shows us that we have added 1 to x. This causes a horizontal shift to the left by a factor of 1. Notice that the x values have all decreased from the previous t-table by a value of 1. T-table 5 shows a vertical shift downward by a factor of 6. Here we see our y values changing. Now, here you can see the final product with all transformations applied compared to the original parent function. The final product is a reflection of the x-axis, significantly more narrow than the parent function. It is shifted to the left and noticeably lower than the absolute function. Hopefully I've made this clear and concise, and thank you very much for watching.